Day 21. So, yeah, I have been slacking quite a bit recently. But they look hard. Should we see what the... Oh, no. The leaderboard looks... Okay, it looks hard. Okay, step counter. You managed to catch the airship as it's dropping someone else off. Okay, you got the sand flowing again. Great work. Now we just need to wait until we have enough sand to filter the water for Snow Island, and we'll have the snow again in no time. While you wait, one of the elves that works with the gardener heard how good you are at solving problems and would like your help. He needs to get his steps in for the day. And so he'd like to know which garden plots he can reach with exactly his remaining 64 steps. Okay, he has steps. Okay, he gives you the up-to-date map, your puzzle input, of his starting position. S, his garden plots. Starting position S, garden plots, dot, and rocks. Okay. The elf starts at the starting point S, which also counts as a garden plot. Then he takes one step north, south, east, or west, but only onto tiles that are garden plots. This would allow him to reach any of the tiles marked O. Okay. After 2 steps, he could reach that many tiles. After 2 steps, he could be at any of the ones marked O. Single third step leads to even more possibilities. Okay. You will continue like this until the steps for the day have been exhausted after a total of 6 steps. So it is unique because you can go northeast, like you can go northwest, southeast, and be exactly where you started. But I'm guessing that doesn't count. So you start here, you go up. Okay, this doesn't look too bad. It must be part 2 that's hard. In this example, if the elf score was to get exactly 6 more steps today, he could use them. Wait, in this example, if the elf score was to get exactly 6 more steps today, he could use them to reach any 16. Okay, if it was 6, okay. However, the elf actually needs to get 64 steps. And the map he's handed you is much larger than the example map. Fine. Okay. This doesn't look terrible. Doesn't look bad at all. So what I think I'm going to do is I'm going to pad this with rocks. Right, I'm going to do rocks. And yeah, it's not bad. I'm going to pad it with rocks so you can have an easier time working with it. I'm going to pad it with rocks. So, okay, great. So we're going to have, basically I'm going to do a bunch of like copying. So var allocator equals standard.heap.page allocator. And we're going to do var grid equals try allocator.alloc. We're going to do input dot, we're going to erase a view 8. Actually const u8, so we don't get type errors there. Input dot length plus 2. We're going to go grid 0 is equal to try allocator dot alloc. We can actually go for 0 dot grid dot length index. So grid at the actually we'll want to do this, and then above here grid 0 is equal to try allocator dot allocate const of input 0 dot length. Is this not working? Can I wrap that like this? No. Exact expression found const. Okay. Oh, it's const for the array. Oh, it must be, of course, yeah. And then same for grid.length -1. And we actually want to do standard.mem.in zero. Is it a zero in it? Dot. Oh, how do I? What's the method for putting the filling thing? Fill? No. Mem.length equal min max copy sort span trim join swap border count split join z. There's going to be some sort of init function. Is there not? Initializes all fields of the struct with their default value or 0. Oh, maybe it's 0 in it. No, it's not that. Oh well, let's just do 0 dot dot input 0 dot length. And then we can just fold it away, I suppose. Grid 0 I is equal to, so we're going to have const rock, which is a hash, const start is equal to s, const garden, which is a dot, and those are the only ones available. Okay. Pretty cool. Grid is equal to, let's do rock, and then also grid.length -1 there to be rock. Grid at the index for each one, let's do I, and then for I. Oh, we can do stand.mem.copy. At memcopy. The destination is grid I, and we're going to copy inputs I-1. So if we're at grid 1, we should be at input 0 there, yep. Okay. Is that all go? Cannot assign to constant. I mean, you sure? If I remove the constant there, then copy arguments have non-equal lengths. Oh, that's true. So we're actually going to have to do for yeah. Oh, and we have to initialize the, yeah. So we have to say these two, these are all equal to rocks, and then we have to do it vertically. So for this length, I0, I grid 0 dot length -1 equals rock. Vertical, horizontal, and then here, now we're going to do that copying. So for 1 dot dot grid 0 dot length take away 1. Grid at ij is equal to input at I-1 j-1. Let's just do a function print grid that takes in a grid of array of U8s, turns nothing, just goes 4, 0, 4. Grid row, 4 row, C, print C, print a new line. There we go, now we can do print grid of grid segfault. Oh, because we have to initialize them all, don't we? Yes. We actually have to go for grid for 0.grid.length. We have to actually initialize them all. And it's just an I there. You think I'd have like a little bit of a generic util for this now, but I don't. Okay, so just a little bit wrong on the bottom there. Wait, what's up with that? Oh, yeah. So there'll be the inner one, and yep. So we have start followed by 4. Wait, only 4 objects. Oh, it should be +2. Grid. All right, I think that's correct now. Yep. Great. We surrounded that all in a grid. Okay, let's there we go. Next, we are at the start. So I'm guessing we have to find the start's position. Find the start position and start moving in places. Yep. Right, so I mean, find the start position. Okay. Bar X is size. Far Y. I'm just going to go for find X and Y, basically grid. And we could have done this when initializing, but it's, you know, row C. If C is equal to start, if a break, outer loop, we can go I 0 dot j, x is equal to j, and y is equal to I. Great. So print x, y. Six. So yeah, 0, 1, 2, 3, 4, 5. Yeah, 6 because we're padding some stuff. Great, that all works. We can get rid of that, or actually ZF around the brackets, so we get rid of the forwards as well. Great. Now next we need to actually move. Let's do const steps equals 6 for 0 dot steps. I can let's go then. Oh, actually, this is gonna drastically change X and Y because it's going to be like various states, right? We're at a. This will basically split into multiple starting points. Multiple starting points. Okay, so every time we are in a loop, we're about to do some steps. We could keep a track of latest steps and start from there. And from there, attempt to go 1 north, 1 east, 1 south, 1. Yeah, that's right. So, current steps is allocator. No, standard dot array list of u128. So we're going to do a binary shift for that. Allocator. I'm actually going to do a little bit of a function. Function chord, which takes in a u size for y and then a u size for this, and returns a u128, which is the shift. So return. So as u128x shift over 64 times, OR with as u128 y. There we go. So for each one, I'm tempted to do the very first one myself manually, like with just the starting. Oh, actually, we can do current steps dot append. We can do current steps dot append. Chord of x and y. Great, and what we go for here is for, and we're going to have bar visited standard dot auto hash map, which is going to act like a set. Really, I want a set. Do they have sets? Set enum set, a set of enum elements. Nope. Dynamic bit set, a bit set with runtime allocator slice. Zig set. Okay, that's not really what I want. Is there a set? Oh god, there's a lot of, yeah. Nah, let's just use the auto hash map between u128 and just Boolean, you know. Okay, so what we're gonna do is gonna go for current steps dot items. Let's do fn x by taking in the coordinate of u128. Returns a u size. Return trunc at truncate. God. At truncate chord shifted to the right 64 times. C and my x, my y, my x, my y, and this is going to be a y, and this is actually going to be just a truncated version of C as a u size. X1, 1, 1. Okay, there we go. Great. So now, what we can do is basically go up, down, to the left. So bar new position is equal. Oh, actually, I'm going to do this, repeat some code here. North is equal to chord. No, I'm just going to say C. C, which is a. Does it know? Yeah, it should know. Yeah. north, which is a u12 weight. So if we go north, that means we're subtracting from y. So actually -1. Because we are encoding the coordinates like this. West, we go c minus at -1. Shift left 64 times. We have to do as u128. There you go. And then the same for east, but to go east we plus it. Right, that makes sense. And what we're going to do is if north is equal to God, actually if let's do north chord equals chord x equals, so this is going to be some repeated code, but you know, it's actually going to be a little bit more efficient. We take the y of that. Instead of north, we do south. Instead of north, we do west. Do east. Okay. Instead of north, we do south. West, west, east. So if grid at north y, north chord y, north chord x is equal to God, and then we're going to do new current steps equals standard array list u128 dot init allocator. And we're going to do new current steps dot append north. And now south chord x. Oh, this should be y first. South chord x, south. West chord y, west chord x, we append west. East chord y, east chord x, east. Okay. New current steps. So we're going to go in each direction. New current steps. We're going to have to remove duplicates there, I'm pretty sure. So if we do have to remove duplicates anyways, maybe we make that a hash map. And then we iterate through the hash map to give it, put it as the current steps. I think that's a better idea. Auto hash map between Q8 and just Boolean. And instead of append, we do put. And we say true or something. There's definitely slightly better ways of doing this, but put true. Because then, yeah, you know, we're not going to get the duplicates, we're going to get the actual new steps. Oh, wait, we have to check if they're not in the original, though. And not, and the current steps dot get current steps dot not current steps, the visited, sorry, the visited dot get north is equal to undefined. Okay, because then, like, we don't want to, we only want to add new ones. Right, yank to the bracket. No, no, yank find. Oh, here. Oh, here. Oh, God, I could have done this by now already. Oh, and it doesn't. Why doesn't it copy the bracket? Okay, I probably did something wrong there. Well, I definitely did something wrong. South, west, east. Oh, and equal undefined. Oh, I was copying until then. Okay. New current steps. Great. So now we have the new current steps, and we're going to do var value iterator, which is new current steps dot value iterator. While value dot next value, that's a U128. No, sorry, it should be key iterator. Key iterator. We should clear out current steps here, actually, before. Steps dot dot d init releases all allocated memory, and we do current steps dot init with the allocator, destroy it, build it again, and we do try current steps dot append the value. And then we have the brand new steps that we're in. Whilst we're at it, we also need to do visited.put the value, which is the key, and then true. All right. Cannot assign to constant. Where 61. Oh, my x, my y. Okay. Try. No field remember it in. Oh, maybe I actually need to do like instead of d init, how do I do current steps dot just remove them all. Can I just d init and var and then say current steps is equal to standard dot array list u128 dot init allocator. Just do that. Okay, 110. Found pointer. Oh yeah, dot star. Dot star. Cool. Okay, that all ran very suspiciously. And I guess after 6, the answer here would be 16. Var part 1, whose size is 0. Part 1 could actually be the visitor dot count. Standard print part 1. Part 1. 28. That's too many. after one step. Two. Oh, we're not counting. Just whilst I think about it, we're not actually counting visitor.put the starting. My x, my y to be true. So then he takes first step, would also count then. Okay, so 0 and yeah, 3 there. Good. It's going to be 3 for us too. Okay, then he takes another step, since at this point it could be either a tile marked O. His second step would allow him to reach any garden plot that is one step north, south, east, or west of any tile they could have reached during that first step. Right, so it can be at 4 new ones. Or is this the fact that we should only count the latest ones? Yeah, I think maybe we only count the latest ones, not the total visited. So actually, let's keep part 1 up there. Let's keep it, I think it's U32. And each time we go around the loop, we do current new steps. We say, oh, and actually we can say new current steps.dinit down here. We can say part 1 is equal to new current steps.count. And that's correct, that's 2. Place it with 6, we get 7. 7's not right. 0, 1, 2, 3, 4, 5, 6. If I replace the U with 7, now I get 8. Oh wait, it's because we don't actually want to ask for this here. Yeah. Delete 2t bracket dot dot dot. $15, which means we are 1 off. Which means we are 1 off. Let's go back a couple. So at 2, at 1 step we can reach 2. At 2 steps we can reach 3. 3 is not right. So something here is wrong. Minus, plus, plus. 1 shifted over 64 times. Yeah. Yep. Wait, not equal to start maybe. No, not equal to rock. Let's do that in a macro, a little bit of training, practice. Find that, go onward forward, go onward back, not go forward, change the word to not be rock, go 3 down, go back to start, and do that 3 times. That gives me 4, let's go back to 6. 16, good. Okay, now we need to do this for 64 times. and 64 times. Oh, no. Oh, I didn't copy the whole answer. I copied 370. Well, that said it's too low, so that's good. I'm going to have to wait a little bit until I submit, don't I? 50 seconds. So, 50 seconds. What can I do in 50 seconds? Just kind of looking around my room. Got all my Christmas shopping done. Everything's done. Currently reading this book, Do Androids Dream of Electric Sheep by Philip K. Dick. I think everyone kind of knows about it. It inspired Blade Runner, or it is Blade Runner. I haven't quite figured it out. I'm reading it to figure out if it is Blade Runner or if it is not. Pretty cool book. Hasn't been a minute yet, but 15 seconds to go. But yes, I'm curious to what part 2 will be for this, because I'm not really sure what they will do. Maybe just a lot more steps. They will just increase the number of steps by a lot. Okay, there we go. Part 1. Great. And now part 2. Yeah, this is probably where it's super hard. The elf seems confused by your answer till he realizes his mistake. He was reading from a list of his favorite numbers that are both perfect squares and perfect cubes, not his step counter. The actual number of steps he needs to get today is exactly 26501365. Oh god. Okay, he also points out that the garden plot and rocks are set up so that they repeat infinitely in every direction. Oh my god, that's a monstrous number. Oh yeah, that is just... Okay, so I mean, this 26501365 steps, and let's assume you can just go straight south, straight north. This times that again is just a huge number. 1, 2, 3. Oh, actually, stuff in the end. I mean, to be fair, I mean, putting them all in memory just is highly inefficient. How are they connected? They are connected. Well, they're just, yeah, side by side. Okay, so my padding approach is like already kind of out the window. Oh god. So padding is out of the window, but we've done part 1. So we can, you know, just leave that out. Now for part 2, we'll take our input, and basically if you go through here, you're gonna end up on the right side there. So basically this has got to do with mod, right? We're gonna have to mod a couple of things. Okay. So we're gonna have to, your x position is gonna be the mod of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, if you're 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, mod 10, so 10 mod 10 puts you to 0. Okay. So we spent a lot of time doing that far one. Maybe we didn't need to. Shame. But it helped. Okay. Next. next, we can just keep our inputs, and we can take a lot of this code. Well, I mean, actually, it doesn't matter what the start. We can keep that bit of code there. And this here, a lot of it can be copied over. Okay, I'm gonna take this. Okay, I'm gonna fold it again. Visited part 2. Did part 2 dot put. As long as I know, these never change again, do they? Yep, no size. No, I'm fine. Okay. Yep. Current steps part 2. Current steps part 2. New current steps, yep. And then current steps part 2. And we'll figure this out. Current steps part 2 dn. Current steps part 2 is a new array list. New current steps, yep. Visited part 2 here. And part 2. E32 is 0. So this is correct, but the thing is, now if you go over to the right once, like if you are here and you reach this here and you go to the right, you're still in the grid, but then you go right once, and I think I have to keep track of that somehow. I have to keep track of where you are on this grid using, oh wait, no, not really. I don't really have to do that at all. I can just keep adding and adding and adding to the coordinates. But then to check on the grid, I can do mod. Okay, so the north coordinates, so the x value is going to have to be modded by the input, the x value. Okay, so input 0.length, and this mod input.length. Oh wait, start again. Mod input 0.length, mod input.length. Let's do that 3 times. That might be it. Part 2 gives me 0, so that can't be it. Let's do it for 1. Right, not that many, just not many. New current steps part 2, current steps part 2, new current steps, yep. So the curious number of things he wanted on spot 2 underscore steps And I have the example input. Yeah, it's a huge number. 26 million iterations of quite memory intensive stuff. I don't know. If n mod, let's see, 10,000? No, 100,000. Print, well, n. To be fair, this shouldn't be too much hard, equals 0. Okay, 100,000. 200,000. 300,000. Okay, I mean, we haven't hit any like boundary, I suppose. So there's that. I mean, the map is gonna get huge. Hash map with 20 million entries. What on earth requires 100 million items? Yeah, I mean, this is obviously huge. So we're up to 1 million. And what is my memory? My memory is at 20 gigabytes. So we are... Oh, but I have swap of 64. Oh, no, I can't. I have to keep them in memory, right? Yeah, so I don't think this is great. I mean, we're up to 1.5. So, you know, I could definitely just go downstairs and, you know, have some dinner. Or eat something else. But the point is that we can obviously optimize this because many of the steps are going to be just repeated. Many of them. Many of the steps are going to be repeated. How do we avoid stuff like that? So after a little bit of trying and brute forcing that approach, it doesn't seem to be working, and I'm kind of running really low on sleep. So I'm gonna call it, and we got beaten by part 2 again. Yeah, I'll have a look on the subreddit because there's probably like much better ways of doing this than just brute forcing, right? There's probably a pattern in the input. There's maybe some caching to be done. It's strange though, I can't even get a simple brute force one to work. Well, anyways, thank you for watching, and hopefully see you tomorrow.